go in and look at the homework right quick. It's actually going to be really easy because, again, Excel will basically do everything for us. So, okay. Let's make it a little bigger. So the waiting times between subdata are uniformly distributed. So uniformly means it's flat. It's the same across the board. What's the probability that a passenger has a waiting time greater than 1¼ minutes? So it could be any number between 0 and 6, right? How do you think you would find the probability of greater than 1¼ ? I wonder if I can draw a picture of it now. Let me see. I'll try to do this while y'all are thinking. Hey, yes, I got a squiggle. So the picture is 0 to 6. It's even across there. I mean, if this all has to add up to 1, what do you think so in order for it to be a probability distribution, I mean, before we had to add up to 1, for the rest of this class, when we're doing continuous things, one of our themes is going to be probability and area are basically the same thing. So I want the area of this rectangle to be 1. If the area of that rectangle is 1, how tall do you think it is? Was that 1? Well, how long is the bottom? Yeah, the bottom is 6 long, right? The area needs to be 1. So what does the height need to be? How do you find the area of a rectangle? Yeah, length times width, right? So 6 times, if this is 1/6 tall, then 6 times 1/6, the area of that rectangle is 1, right? Okay. Now what we care about is here at 1.25, I just want to know what's the probability of being greater than 1.25. So I want to know, hey, what's that area? Yeah, so the height is 1/6. The base is 6 minus 1.25, which is 4.75. And just length times width. Is 0.791, whatever. 3 decimal places. So 0.792. All right, so that was easy. Let's go to about 5. Okay, so now this is it says the graph depicts the standard normal distribution. So if you were doing this in like 20 years ago, what you would have to do is pull up these tables and look, find all that's horrible, ain't it? You want to do that? No, let's not do that. So the area of the shaded region. The shaded region is to the left. And I mean, the first thing you need to remember is Excel always gives you area to the left. So it's asking for what Excel is going to give us anyway. So all I need to do, Z is 0.94. We go to Excel. And I say, hey, this is equal to the norm S dist, standard normal distribution, 0.94. And from here on out, the rest of the class, the cumulative, it's always 0 or 1. It will always be 1 for the rest of the course. So there you go. That was easy, wasn't it? And that will round up to 4. Let's do another one like that. Okay, now we got area to the right. So what's going to change? Yeah, so Yeah, you could actually do a couple things. To find area to the right, kind of the easy way is say, oh, well, it's 1 minus the area to the left. So go 1 minus norms this. The other thing is, since it's actually the picture symmetric, I could just do area to the left, but change the 1 to +1. And it would actually do the same thing. But so let's go ahead and do that both ways, just for the grins of it. So area to the right would be 1 minus norm S dist negative 1.02. And I do want cumulative. So, or on the other hand, since it's all symmetric, I could just go norm S dist, make it positive 1.02. Oops. Oh, sorry. And I still need to put comma 1. Yeah. So either way. And this is 4 decimals. All right. Let's go to about 8. Okay, we're still there. Oh, it doesn't have either side shaded. It wants to know, hey, what's the... Wait, it says it just wants the z-score. Oh, okay. Sorry. For a second, I was like, what in the world are they talking about? So I think it wants this to be shaded, and it just didn't shade it. All right. So it's... Now we're doing the opposite. So a while ago, we knew what z we wanted to cut off at. We were looking for the area. Now it says, hey, here's the area I want, 0.9599. What z should I cut off at if I want to get that area? So we need to know, hey, what's the opposite of the normal distribution? Which whoever named it did a really good job. So let me just recap. So the normal distribution, this is if you have z and you want the area. This is norm S dist, z comma 1. If you want to go the other way, so you have the area you want and you want to find z, well, it's norm S inverse. And just put it in the area. All right, so for this one, we're just going to say norm S inverse, and the probability was 0.9599. So Z is 1.75. Yeah, so you can see what I typed in. It's norm S inverse. It's probability there. And we only want 2 decimals, so that'll be 75. Let's do another one like that. Found the z-score. So again, they give us the area we want z. So I'm just going to say norm S inverse, 0.1788. There's no z. Two decimals would be 0.92. Let's find one where they don't give us area to the left. Let's try about 11, see what it is. Okay. So now we're going to think for a second. Now they gave us the area to the right, right? Well, the inverse is just like the other one. The other one spits out area to the left. So when we use the inverse, we need to put in area to the left. Yeah, so we're going to go 1 minus the shaded area first. That'll give us area to the left. Then we plug that guy into our inverse. So the first thing we're going to do is go 1 minus 0.1894. That was right? Yeah, 1894. So my area to the left is 0.8106. And so I do norm S inverse 0.8106. And 2 decimals. Oh. All right. So this is a word problem. We like word problems, don't we? It's where like the math hits the real world. I know Merced likes word problems, don't you? Okay, it says the readings are normally distributed with mean of 0 and standard deviation of 1. What happens when you don't have mean of 0, standard deviation of 1? We'll learn in a second. But right now it says probability of the randomly selected reads greater than 0.97 and draw a sketch of the region. So, which looks like the right picture? Says we want the probability that it reads greater than 0.97. Yeah, the first one. All right, and the probability, so this time we know the z we want, which is 0.97. We're looking for the area, which is the probability. So if we know the z and we're looking for area, do we use the dist or the inverse? Yeah, we use the dist, right? And we're looking for area to the right. So we know dist will give us area to the left, so we'll do 1 minus once we get it. So we're going to go 1 minus norm S dist 0.97. Whoops. And I keep on forgetting that I have to write comma 1 every time. So we've got a 16% chance, 4 decimals, so of it reading that high. Let's see if the next one is also a word problem. It is, but it's the same sort of one. So actually, we haven't done one of these yet, though. So if we want between 1.5 and 2.25, so there's the picture. How do you think we would get that with our calculator? Okay, I want to the left of 2.25, so that's norm dist 2.25, right? But I do not want to the left of 1.5. So how am I gonna say not to the left of 1.5? Well, it's just like what we were doing before when I did area to the right. Area to the whole thing we know is 1. If we don't want the area to the left, we subtract off that left area, and what's left is the right. Same thing here. If we know the area to the left of 2.25 is whatever it is, if we subtract off the area to the left of the 1.5, that'll give us the area in between it. Right? So that's all we're going to do. We're going to say, hey, we want to do the area to the left of the 2.25, which is norm S dist 2.25. But we don't want to the left of 1.5, so we go minus norm S dist 1.5. That makes sense? All right. And that'll round up to a 6. Cool. All right. So that's all the standard normal distribution. Let's jump down and find one where we don't have the standard normal distribution. Okay, it says adults have an IQ score with the mean of mu 105, standard deviation of 20. Find the probability of an adult having less than 145. So let me tell you one thing just in case it comes up. I don't think I put any of this in here since we're doing Excel. Well, there we go. So there's a trick for turning any distribution into one that has mean 0, standard deviation 1. It's just, hey, take your number minus whatever the mean is, divide by the standard deviation. So like for this problem, the IQ score we care about is 145. The mean was 105. The standard deviation is 20. So that's 2. So to do this problem, you could do norm S dist, or sorry, yeah, that's right, 2. That said, the wonderful people who programmed Excel give you another option. If you just don't want to worry about finding the z-score or whatever, you don't have to. All you have to do is take the S out of norm S dist. So instead of, remember that S stands for standard, so instead of standard normal distribution, you just say normal distribution. The trade-off is you have to actually put in what the mean and the standard deviation are now. So you put in the value you care about, the mean, the standard deviation, and 1. So you can put norm dist 145, 105, 20, and 1, and it'll do the rest for you. Okay. So let's do that both ways just to see if they really do get the same thing. So I could have went norm S dist 2 and got that. Or now I can also just say, hey, I want norm dist my 145. My mean is 105. My standard deviation is 20. And 1. So either way, gives you the same thing. Let's jump to 19. Let's say that's the same question, but that's because the new question hasn't loaded yet. How are you feeling, Merced? Okay, assume adults have IQ scores normally distributed with 100 standard deviation of 15. What is you want to find the bottom 4 percentile for IQ scores. Okay, so let me ask you a question. The first question you always ask yourself. Do we know the value and we're looking for probability, or do we know the probability and we're looking for the value? You can make the question bigger if that would help. That probably would help, wouldn't it? Yeah, we're looking for the value. We know that we want that area to the left to be 0.04. We're looking for the bottom 4% of people. We want to know, hey, what value will give us that? So if you know the area and you're looking for the value, are you using the dist or are you using the inverse? I can go back to where I wrote it down a second ago. That would help. So if you have the area and you want the value, you use the inverse guy. On the other hand, if you have the value, you want the area, you use the dist guy. So let's go back. IQ score was 100 and standard deviation of 15. All right. So just like the other one, if we're not doing the standard normal, you just take the S out. So I'm going to go norm inverse. The probability I care about, well, I want the area to the left to be 0.4. The mean is 100. Standard deviation is 15. All right, so if you have an IQ of 74, I'm sorry to say you're in the bottom 4%. Nobody has an IQ of 74 in here, though. Y'all are all the smart people, or else you wouldn't be taking this class. So. All right. Okay, so same thing. We got, I guess they like IQ in this, don't we? Mean is 105, standard deviation is 15. It wants to find the one that separates the top 25% from all the others. All right. So again, we know the percent we want, we're looking for Z. So we're going to use the inverse. So norm inverse. Okay, remember when I put in my guy, I always want to put in area to the left, right? I'm looking for the top 25%. So what's my area to the left going to be? Yeah, 0.75. And it said the mean was 105, standard deviation was 15. 115. One decimal place. Let's do a couple more. Let me call it good for today. I'll get us halfway through homework 5. Okay, a common design requirement is the environment must fit people that fall below the 5th percentile for women and the 95th percentile for men. Designing a work table, sitting knee height must be considered, which is the distance from the bottom of the feet to the top of the knee. Males have sitting and knee heights that are normally distributed with 21.1 inches, standard deviation of that. Females have knee heights that are normally distributed with that and standard deviation of that. Use this information to answer the following question. So what table clearance, if you want 95% of men to not hit their knees when they sit at this table, how tall does it need to be? feel like I'm reading this backwards, but maybe I'm not. Okay, it says they're normally distributed 21.1, standard deviation of 1.2. So I want 95% of men, so I know the percent. So am I using dist or inverse? Inverse, yeah, so norm inverse. I want 95% of men. Oops. And men are 21.2 and 1.2, is that right? 21.1 and 1.2. No, 1.1. So if you want 95% of men to sit at this table, then it needs to be 23.1 inches tall. Is it? It's yeah. The common sense dictates, but I mean, we could punch it in and actually find the bottom 5% of women if we wanted to. But if you're in the 95th percentile of men, so you're towards the top of men leg length, you probably have longer legs than someone who's towards the bottom leg length for women. So, yeah, there you go. Cool. The author is writing an exercise at a table with that. What percentage of men fit at a table? Okay, so now if we know the cutoff, 23.6, we want to find, hey, what percent of men would actually fit under this table? How do we do that? Yeah, it's norm dist because we know the cutoff we want. We're looking for the percent. So go back. So norm dist, 23.6 is the cutoff. 21.1 was my mean. 1.2 was my standard deviation. And I tack a 1 on the end of it. So 98% of men should be able to fit at that table. So that would be 0.14 and make it a percent. Make good sense? All right, that's probably a good place for today.